Hello, welcome to today's class again. Here we have a question before us here. The question is, which is greater between 1000 to the power of 1001 and 1001 to the power of 1000? How? How do we solve for the value which has the greater expression, or the quantity which has the greater value? So from here, let's take our solution first. If you're new here, this is my Prowess, and if you've not subscribed, subscribe so that you get our videos when they are released. Okay, now we're going to take some theory. One of the things we have to put into consideration here is that if we have A and B, or if A and B are two numbers greater than E, okay, we have A and B. They are two numbers that are kind of greater than our E, and A is less than B, okay, and A is less than B, then we can conclude that B to the power of A is less than A to the power of B. We are going to prove this in a while, okay? This is true if and only if, because the condition to the statement here now is easy. Okay, let's put it in writing. If and only if B to the power of 1 all over B is less than A to the power of 1 all over A. If we can show that the function, okay, if we can show that the function f of x, for instance, equal to 1 all over x, that is to say, this when I give us e to the power of ln of our x to the power of 1 all over x. In other words, we can, this expression we have here now is the same thing as this. Why? Because we know that e to the power of ln is, this ln here is base e. So this will leave the system to give us this. So we can rewrite this expression here in this format here. And again, we can apply the law of logarithms, which says that if you have your log, let's take our m to the power of n, move this exponent back here to give us our n times log our m. Okay, so if we apply this, then we can move this as an exponent back here. So if we do that, so this is going to give us something of this kind, our e to the power of 1 all over x, the ln of x, which is same thing as our e to the power of ln of x all over x. But this is a decreasing function if you look at it very well. On the interval of our e, okay, and what? Infinity. So if this is a decreasing function, so let's find the derivative of our f of x. So from here, let's go ahead and find the derivative, the f prime of f of x. Okay, so if we find the derivative, this is going to give us x times our 1 all over our x minus the ln of x, everything all over x to the power of 2 after differentiating, right? And we know that this will leave the system, so we're now left with 1 minus ln of x all over what? X to the power of 2. So from this function, automatically this is going to give us what? 0. And so from this proof so far, we now discover that our x is equal to what? E. And that is the condition given in the first instance, that if and only if A and B are numbers greater than or equal to E. So we have shown from this expression that our x is equal to what? E. So with that, these will hold water. Okay, so if this hold water, we cannot come to a conclusion that thus, cannot say thus, thus, where our 1001 to the power of 100 is less than 1000 to the power of 1001. That is what it means. Okay, if you have two numbers a and b between 0 and e, and a is less than b, then a to the power of b will be less than b to the power of e, or to the power of a rather. So this might not hold water for some conditions. we're saying here that say if the two numbers a and b are between 0 and e, in other words, a and b are not equal to or greater than e. So on that ground, we're going to have a to the power of b, we're going to have a to the power of b will be less than b to the power of a. Unlike the first theory we established here. So if you look at this carefully, this establishment has to do with our a and b are either greater than or equal to e. But in this regard, then our a and b will exist between 0 and e. But again, at times we might run into some trouble or some challenge if we have an expression whereby we have 1, then less than a, less than e, less than b. In this case, what happened? It is not so easy to tell which of a to the power of b and b to the power of a is larger. So we can't really tell if we have this condition here. So to prove that a to the power of b is less than b to the power of a, or a to the power of b is greater than b to the power of a, it will be very, very difficult. I may produce a video on a case scenario that has to do with this. But if you want me to make a video on a case scenario that has to do with this, drop it in the comment section. Just say case scenario. Then I will drop it in no distant time. So this brings us to the end of this proof, this challenge here. All right. So if you learned something from this video tutorial, give this video a thumbs up. And if you're not subscribed, do it to subscribe. And when you subscribe, turn on the bell notification button so that you get notified whenever we drop an amazing video like this very one you just watched right now. Thanks for being there. Bye.